Hello everyone. In the previous class, we had discussed about 4-bar chain, and based on the Greshov's law, we have seen how the 4-bar chain can be modified into various types of mechanism. In today's class, we will continue from the discussions from the previous class. Here, we will be discussing about two more chains, and we will see what are the different types of mechanisms that can be developed from that kinematic chain. The two more kinematic chains that we are going to discuss today are single slider crank chain and double slider crank chain. Single slider crank chain is a modification or the modified version of a 4-bar chain. As we have seen, 4-bar chain consists of 4 links and it has 4 kinematic pairs, and all these kinematic pairs are turning pair. Similar to a 4-bar chain, a single slider crank chain also has 4 links. It also has 4 kinematic pairs, but out of the 4 kinematic pairs, one kinematic pair is a sliding pair and rest of the 3 kinematic pairs are turning pairs. Now, as I have told you, in a single slider crank chain, there are 4 links. When each of these 4 links are fixed, then we can create a separate mechanism. So, a phenomenon where by fixing one of the link in a kinematic chain creates or develops a mechanism, this phenomenon is known as inversion. That means, as we know that for a single slider crank chain there are 4 links, then by fixing each 4 link we can develop 4 different mechanisms, and we call these as 4 different inversions. In a single slider crank chain, when the first link is fixed, we call it as inversion 1, and the mechanism that is developed by fixing the first link of a single slider crank chain is a reciprocating engine mechanism, or in other words we can say it as the slider crank mechanism. A slider crank mechanism consists of a crank, a connecting rod and a slider. It has got 4 links, the first link being the frame. The crank of a single slider crank chain, a slider crank chain has a rotational motion. It can rotate in the clockwise or anti-clockwise direction, and the 4th link, which is the slider, has a translatory motion which can move along x-axis. The slider crank mechanism has 4 kinematic pair, that is pair 1 2, pair 2 3, pair 3 4 and pair 4 1. Okay. Out of these kinematic pairs, only the pair 4 1 is a sliding pair. Rest of the pairs are turning pairs. That means pairs 1 2, 2 3 and 3 4 are turning pair, and only pair 1 4 is sliding pair. In a single slider crank chain, instead of link 1, if link 2 is fixed, then we get the second inversion. In this inversion, link 2 will be fixed, due to which link 3 will be the crank, and link 4 will be the sliding pair. That means pair 1 4 is sliding pair, and pair 1 1 is turning pair. Link 2 will be fixed, due to which link 3 will be the crank, and link 4 will be the sliding pair. That means pair 1 4 is sliding pair, and pair 1 1 is turning pair. and the crank along with the slider 4 will rotate about this particular center point. Let's say it is O. Also, link 1 will also rotate about this point. Let's say P. And the slider will have both translatory motion as well as a rotational motion. The application of inversion 2 of single slider crank chain is the Whitworth quick return motion mechanism. That is what is shown in the figure. In the Whitworth quick return motion mechanism, as in the inversion 2, link 2 is fixed. Link 3 is the crank, which is connected to the slider link 4, and link 3, which is the crank, rotates about O4, and the slider also rotates about O4 as well as it slides along link 1. Link 5 is pivoted to link 1, which is connected to the ram. The Whitworth quick return motion mechanism is basically or mainly used in devices used for cutting metals. So at the ram, you will be connecting the cutting tool. The ram will be having a translatory motion, and the motion will be along the x-axis. The direction of motion of the ram will be perpendicular to link 2. In the Whitworth quick return motion mechanism, the crank 3 will rotate in the anti-clockwise direction. During the start of the stroke, the slider, that is 4, will be at point Q. Point A will be at A1, and the ram where the tool is connected will be at the extreme left position. When the crank rotates in the anti-clockwise direction, the forward stroke of the ram will start, and at the end of the forward stroke, that is when the slider moves from Q to P. Okay. Point A will move from A1 to A2. Okay. During that forward stroke, the ram will start moving from the extreme left position to extreme right position. That is the forward stroke. During the forward stroke, the angle the slider sweeps, that is angle QO4P, that is this angle, is known as alpha, and the angle alpha is proportional to the time taken by the tool for the forward stroke. Now after the forward stroke, the slider will continue its motion. That is, the slider will move from now P to Q. Okay, and point A will move from A2 to A1. Thereby, the cutting tool will start moving from extreme right position to extreme left position. So the angle the slider sweeps, that is P04Q, which is termed as beta, is proportional to the time of return stroke. So the ratio between, this is alpha, so the ratio between time of forward stroke and time of return stroke equal to alpha by beta. So if you are given alpha and beta and one of the time, you can find the other time. This video shows the working of a Whitworth quick return motion mechanism. You can see that the forward stroke takes more time compared to the return stroke. So this is to enable the cutting of the metal during the forward stroke. When the third link of the single slider crank chain is fixed, we get the third inversion. One of the application of the third inversion is the crank and slotted lever mechanism. In a crank and slotted lever mechanism, link 3 is fixed link. Link 2 acts as the crank, which rotates in the clockwise direction. Link 1 is the slider and link 4 is the slotted lever. The slider has both rotational motion and a translatory motion along the slotted lever. The slotted lever undergoes a reciprocatory motion about O. Basically, the slotted lever 4 will have a rotational reciprocatory motion. Okay, so this will move in this way about B. And link 5 is connected to the slotted lever 4 and thereby it is then connected to the ram or the tool. Like in the case of the Whitworth quick return motion mechanism, in the crank and slotted lever mechanism also, the forward stroke of the tool will be slower compared to the return stroke. Like in the case of Whitworth quick return motion mechanism, here also you have angle theta, which is the angle swept by the slider during the forward stroke of the tool, and beta is the angle swept by the slider during the return stroke of the tool. So the ratio between the time of forward stroke and the return stroke is given by theta divided by beta. Another application of inversion 3 of a single slider crank chain is the oscillating cylinder engine. This video shows a oscillating cylinder engine where the crank of this engine is link 2, link 3 is the fixed link, that is the frame, and link 4 is the oscillating cylinder and link 1 is the piston. When the fourth link of the single slider crank chain is fixed, we get the fourth inversion. The application of fourth inversion is a mechanism for the hand pump. In a hand pump, the frame is the fixed link, that is link 4. Link 1 is the piston, and the link 2 is the link that connects the piston with the frame. This video shows the working of the hand pump. Now the third type of kinematic chain is the double slider crank chain. A double slider crank chain consists of 4 links. That means there are 4 pairs. Out of the 4 pairs, 2 pairs will be sliding pair and 2 pairs will be turning pair. In a double slider crank chain, pairs 1, 2 and 1, 4 will be sliding pairs, and link or pair 2, 3 and 3, 4 will be turning pairs. When we fix the first link in a double slider crank chain, we get the first inversion. That is what is shown in this figure. In the first inversion, link 1 is fixed. So in this particular mechanism, we have 4 links and 4 pairs. Here also 2 pairs are sliding pair and 2 pairs are turning pair. That is 1, 4 and 1, 2 are sliding pair, and 2, 3 and 3, 4 are turning pairs. One of the application of this inversion is the elliptical Dremel, which is used to trace an ellipse. The link 1, which is the fixed link, acts as the gateway for the sliders 2 and 4, and these sliders are connected by a connecting rod 3. The sliders can move either along horizontal axis or vertical axis. In this figure, slider 4, and that is link 4 and link 2, that is link 4 can move only along horizontal axis or x-axis, and link 2 can move or slide along vertical axis. Now, any point on 3, when the slider slides, any point on link 3 other than the center point will trace an ellipse. So if you want to draw an ellipse, you can use this mechanism. This video shows the working of the elliptical Dremel. You can see, if you take a point on the connecting link between the 2 sliders, it will trace an ellipse. This applies to any point except the center point of the connecting link. When any of the sliders in the double slider crank chain is fixed, we get the second inversion. In the second inversion, link 3 will be the crank, that is, it undergoes a rotational motion, and link 1 will have a reciprocatory motion along the x-axis. Such a mechanism is known as a Scotch yoke, which is a mechanism which converts the rotational motion to translatory motion. What is shown is the Scotch yoke mechanism. Here you can see the rotational motion of the crank is converted to the reciprocatory motion. When the third link of the double-threaded crank chain is fixed, we have the third inversion. The mechanism that is developed is known as an all-damped coupling mechanism, which is a mechanism which is used to connect parallel shafts. You have 3 or 4 links where link 3 acts as the support, link 2, link 1 and link 4 is in the form of a disc, with link 2 and link 4 having a slot, and link 1 has a tongue like projection on either side. Link 2 and link 4 are connected to the shafts, the two connecting shafts, or the shafts that has to be connected, and link 1 is connected to link 2 and link 4 with the help of the tongue. Okay, the tongue slides into the slots provided in link 2 and link 4. What is shown is the all damped coupling. This is link 1, which has got two tongues on either side. This is link 2 and link 4, and this is the all damped coupling arrangement. So the shaft slides on one side of the all damped coupling, and the other shaft slides on the other side of the all damped coupling. So this is the way the parallel shafts are connected.